Welcome to the Career Research Channel. Today we are doing a deep dive into something that is, frankly, going to change the global technology landscape. But really quickly, right before we jump in, please take a second to hit that like button and subscribe to the channel. It really helps us keep bringing you these deep dives.
Yeah, definitely hit subscribe. We've got a lot of ground to cover today.
We really do. So I want to start by transporting you back to a very specific, incredibly tense room in Seoul.
Oh, I know exactly where you're going with this.
Right. It's March 2016. And sitting at this table is Lee Sedol, who is, arguably one of the greatest Go players in human history. And across from him is AlphaGo, which is an AI system built by Google DeepMind.
The atmosphere in that room was it was heavy. I mean, for a tech-savvy audience, the story of AlphaGo is pretty familiar, but the mechanism of why it mattered is it's crucial context here.
Yeah, because Go isn't just checkers.
Exactly. Go has more possible board configurations than there are atoms in the observable universe. You literally cannot brute force it. So before 2016, computer scientists thought, an AI would need decades to master the game because it requires something akin to human intuition, the ability to look at a board and just feel the right path without calculating every single future move.
Right. The AI couldn't just, check every leaf in the forest. It had to learn how to map the dark forest by feel. And then, and this is the crazy part, AlphaGo played Move 37.
Move 37, yeah.
A move so totally alien that human experts watching thought it was a glitch. They thought the machine broke.
Okay.
Let's unpack this. That exact moment shattered the illusion that intuition was this exclusively human domain. It was a profound shock to the system, especially for a highly digital, hyper-connected country like South Korea. I mean, it was a national wake-up call.
That absolutely was.
Right.
Which is what makes what is happening right now so compelling, because exactly 10 years later, we're looking at 2026 now, Google DeepMind is returning to Seoul.
But not to play a board game.
No, not for a demonstration, not for a game. They are signing a memorandum of understanding with South Korea's Ministry of Science and ICT, and they are building a dedicated AI campus. And this facility is entirely tethered to this massive state-sponsored initiative called the K-Moonshot.
Wait, okay, so this isn't just about making my smartphone smarter or summarizing my emails, because to understand why a massive Silicon Valley tech giant is embedding itself into a sovereign nation's scientific infrastructure, we have to look at how the entire paradigm of AI has shifted. We're totally out of the era of parlor tricks and chatbots, right?
Completely. DeepMind's entire architecture has pivoted to a field that they call AI for science.
AI for science, got it.
Yeah, and the big inflection point for that pivot was AlphaFold. So biologists had spent half a century grappling with Leventhal's paradox.
Which is the protein folding thing.
Exactly. It's this idea that a protein can fold into just an astronomical number of three-dimensional shapes based on its amino acid sequence. To figure out a single protein structure through traditional physical experiments, like using X-ray crystallography, that could take years of just pure trial and error. But yeah. AlphaFold completely sidestepped that physical bottleneck.
By using pattern recognition, right? It essentially looked at massive databases of evolutionary data and just learned the underlying rules of how proteins fold. So it predicts the 3D structures in minutes instead of years.
Yeah.
And the impact of that is just so absolute that Demis Hassabis and John Jumper from DeepMind, alongside David Baker, they actually won the 2024 Nobel Prize in Chemistry for it.
Yeah, a Nobel Prize for an AI breakthrough. And what's fascinating here is the sheer scale required to achieve that kind of result. The models driving AI for science are what we call frontier models.
Okay, define frontier models for a sec.
Sure, they are these massive systems trained on supercomputers that operate at the absolute edge of current scientific capabilities. You cannot just build or deploy these frontier models in some isolated California lab. You require a highly integrated ecosystem.
Meaning you need a lot of physical stuff to make the digital stuff work.
Exactly. You need unimaginable amounts of compute, which means vast centralized server farms. You need specialized hardware, complex supply chains, and crucially, deep domain experts to actually verify if the AI's digital predictions work in the physical world.
And that answers the central question of what we're looking at today. Why Korea? Because when I hear the term AI campus, I immediately picture, ivy-covered brick buildings, sprawling lawns, maybe some dormitories.
Right, a traditional university.
Yeah. But this is something entirely different. This is a hyper-focused hub situated directly inside Google's existing Seoul offices. It is an access bridge. It's designed to plug Korean scientific talent, local hardware startups, and these massive industrial players directly into DeepMind's frontier models.
And that physical proximity is very deliberate. The campus serves as a localized node to bypass this massive hurdle in modern AI development. It's known as the sim-to-real gap.
Sim to real gap, simulation to reality.
You got it. See, in a digital simulation, an AI model operates perfectly because the rules of the software are absolute. There's no win, no friction. But when you try to apply that AI to a physical process, say operating a robotic arm or managing a complex chemical plant, you encounter real-world friction. You get sensor noise, temperature fluctuations, material degradation. The AI's digital perfection basically falls apart in the messy physical world.
Ah, here's where it gets really interesting. Korea is arguably the most advanced physical test bed on the planet. We often think of Korea in terms of, cultural exports like K-pop or dramas, but beneath that is a hardcore, incredibly dense manufacturing powerhouse. We are talking about titans like Samsung and SK Hynix. They literally drive the global semiconductor supply chain. They lead in batteries, shipbuilding, biotech, advanced materials. So while a lot of regions globally are pouring billions into building AI that talks, Korea want to build the infrastructure for AI that builds.
And that distinction is huge because it is fundamentally harder to build AI for heavy industry than it is to build a text generator. Think about it. If a language model hallucinates a word in an email summary, it's a minor inconvenience.
Right, you just delete the sentence.
Yeah. But if an AI hallucinates a parameter while optimizing, say, the chemical vapor deposition process in a semiconductor fabrication plant,
Oh, wow.
it ruins millions of dollars of hardware instantly. So to bridge that sim-to-real gap, DeepMind needs access to the highest fidelity, most complex manufacturing data in the world. And Korea's industrial base provides exactly that ground truth.
So it's a mutual exchange. DeepMind gets the ultimate industrial sandbox, and Korea gets to anchor its STEM talent. Because brain drain is a really critical vulnerability for Korea right now. Top-tier engineers often leave for the immense salaries and resources of the U.S. tech hubs. By planting this campus in Seoul, Korea creates this massive gravitational pull. You don't have to move to California to work with frontier models. The frontier models are basically brought to your doorstep.
That's spot on. That talent retention is the core engine for the Korean government's ambition. South Korea does not want to just be a passive consumer of AI software. They want to lead. And the K-Moonshot initiative we mentioned earlier, that is the framework for that ambition.
So the K-Moonshot, they're taking the old Apollo program concept, pointing the entire resources of a nation at a seemingly impossible goal, and aiming it at scientific bottlenecks.
Yes, specifically targeting areas where traditional research is just agonizingly slow. We're talking about drug discovery pipelines that usually take a decade and billions of dollars. We're talking about inventing entirely new advanced materials for electronics, running hypocomplex climate models to manage national energy grids.
And DeepMind has already proven they can build the software for this, haven't they?
They have. They've mapped out millions of new crystal structures for material science using their Genome E model. They've built highly advanced weather forecasting systems. It's essentially a lock-and-key fit. DeepMind brings the software architecture to navigate this vast chemical space, and Korea brings the heavy hardware and the national mandate to actually manufacture the results.
Okay, but exploring that chemical space requires staggering amounts of computational power, right? Having an AI model simulate the properties of millions of potential molecular combinations to find, a better solid-state battery material, the compute costs for running those simulations at a national scale have to be astronomical.
Oh, astronomical is an understatement. It's incredibly expensive.
Okay, so I have to push back here then, because this all sounds incredibly synergistic on paper. But if Korea is leaning this heavily on Google's cloud compute and DeepMind's frontier models to achieve their K-Moonshot, are they actually building their own rocket? Or are they just buying a really expensive ticket on Google's ship?
That is the million-dollar question.
Right, because the risk of digital colonialism seems massive. If a Korean biotech startup uses Google's infrastructure to discover a revolutionary new drug, who actually controls that intellectual property, are they risking total dependency on a foreign platform?
It's a very valid concern, but the harsh reality is that buying the ticket might be their only viable option right now. The barrier to entry for training native state-of-the-art frontier models from scratch, it's tens of billions of dollars in specialized silicon and raw energy.
Tens of billions.
You have to look at the global map. The U.S. possesses these massive organic ecosystems companies like OpenAI, Google, Meta, and they're backed by practically endless venture capital and proprietary server farms. Then you have China, which is leveraging state-backed data silos that are deeply integrated into their vast manufacturing base.
Right, what about Europe?
Europe has essentially positioned itself around regulation. They're attempting to dictate the market through compliance and safety frameworks. Meanwhile, the Gulf states are just aggressively buying raw infrastructure, pouring billions into compute clusters.
And Japan is highly specialized, right? They're focusing intensely on applying AI and robotics to solve the demographic crisis of an aging society.
Yeah.
So looking at that map, Korea is trying to carve out a very specific niche, the compact, hyper-fast, highly advanced AI industrial hub. But to your point about the barrier to entry, if they can't afford to build the foundational engines from scratch at the scale of the US or China, their only strategy has to be mastery of the application.
Exactly. And if we connect this to the bigger picture, the limiting factor globally isn't just silicon chips, it's human capital. The campus in Seoul is explicitly designed to address this talent bottleneck. But the most valuable people they train over the next decade won't necessarily be hardcore machine learning engineers spending their days writing algorithms from scratch.
No.
No, we are seeing the rise of what we call the hybrid expert.
A hybrid expert. Okay, so that's the idea, that you don't need to know how to build a GPS satellite from scratch, but you absolutely need to be the ship's navigator who knows how to use its coordinates to avoid crashing into a reef.
Precisely. That is the perfect analogy. The future of the economy belongs to the biologist who understands how to steer a frontier model to find a target protein. It belongs to the climate scientist who can leverage machine learning to predict monsoon disruptions on global supply chains. Or the material scientist who knows exactly which parameters to feed an AI to discover a lighter aerospace alloy. Korea recognizes that to dominate the application of AI, they need to train an entire generation of these hybrid practitioners across all their heavy industries.
And when that specialized talent pool matures, they're going to inevitably build companies. Seoul and the nearby Panjo Tech Valley, which is kind of like Korea's Silicon Valley, they already host a really vibrant startup ecosystem.
They do. It's very active.
But local startups historically hit a ceiling when trying to scale internationally. They might have brilliant engineering, but they lack the global distribution networks and the immense, flexible cloud compute that a giant like Google just naturally possesses.
And that's where the AI campus functions as an accelerator for that exact problem. It gives these nimble, innovative startups access to models that are way too expensive for a small team to train independently. But this raises an important question, going back to your earlier concerns about dependency. How does Korea manage the integration of a foreign tech giant into its sovereign data streams?
Because training these hybrid models requires access to highly sensitive industrial telemetry and medical records.
Exactly. It's a massive security and economic puzzle. Will this partnership genuinely empower independent researchers and agile startups? Or will access to the AI campus effectively be restricted to just a few elite state-backed universities and the massive conglomerates like Samsung?
Right, because a true test bed shouldn't just reinforce the existing monopolies. It needs to build new economic muscle. It needs to give the little guy a chance to use these tools.
Which brings us to the metrics of success. We actually have a clear scorecard for what observers should be tracking over the next 12 to 24 months to determine if this initiative actually alters the global landscape or if it simply fades into corporate PR.
Okay, let's go through the scorecard. First on the list is the physical reality of the campus. When the doors actually open, what are the tangible programs? Are we looking at just a glorified networking space for executives to drink coffee? Or are there hardcore, fully funded research residencies for postdocs and founders?
Exactly. Second is the alignment of the initial joint research projects. If the first major announcements involve AI for next-generation energy grid management or complex materials discovery, that signals a genuine commitment to the K-Moonshot.
But if the projects skew toward consumer software or ad optimization,
Then the industrial ambition is completely hollow.
makes sense. Third is the inclusivity of the talent pipeline. Does a brilliant young engineer with an unconventional startup have a real, transparent pathway to get compute time on a frontier model? Or is it a closed club for legacy institutions?
And fourth is the establishment of technical safety frameworks. Applying AI to the physical world requires entirely new paradigms for system verification. How Korea and DeepMind handle the safety parameters of autonomous systems in manufacturing or chemical synthesis, that will likely set the technical standard for the rest of Asia.
We've really traveled a vast distance in this deep dive. We started with the sheer cultural shock of a Go board back in 2016, a moment where AI proved it could navigate the dark forest of human intuition. And we've arrived at this highly structured, intensely physical K-Moonshot in 2026. Korea has essentially positioned itself as the crucible for the next phase of artificial intelligence. They are taking these massive frontier models out of the digital ether and forcing them to confront the messy, unforgiving realities of science, manufacturing, and that sim-to-real gap.
It really marks the transition from AI as an isolated oracle that can outthink us in a closed system to AI as an industrial engine that works alongside us to manipulate the physical elements of the world.
So what does this all mean for you listening right now? Why does a facility in Seoul matter to your daily life?
Yeah.
Because the experiments happening there, this fusion of cutting-edge software with hardcore physical manufacturing, they're going to dictate the timeline of your future. It's going to determine the speed at which the next generation of life-saving therapeutics hit the market. It's going to shape the efficiency of the solid-state batteries in your next car and the materials used to build your city's clean energy grid. The AI race is no longer confined to server racks and chat interfaces. The battleground is now the physical world.
It's a profound shift. And building on the concepts we've explored today, I want to leave you with a final thought to mull over regarding your own trajectory. Consider the rise of the hybrid expert we talked about. The economic advantage over the next decade belongs to those who fuse deep, specialized domain knowledge with the capability to steer complex AI tools. Look closely at your own profession, your own field of expertise. What does the hybrid version of your job look like in 3 to 5 years? As these systems become deeply integrated into every physical and intellectual workflow, are you actively preparing to be the domain expert who directs the model, or are you waiting for the model to direct you?
That is an essential question to ask as the technology moves from the game board to the real world. This has been Korea Research. Thank you so much for joining us on this deep dive. And don't forget to like and subscribe if you haven't already. We'll see you next time.